Hello, welcome to the Electronic Home Workshop. Today in the workshop we are going to talk about the OR gate and the NOT gate. That is the OR gate and the NOT gate. Now let's look at the two different types of gate. First, let's consider the OR gate here. The OR gate. So what is actually the OR gate? OR gate is when two switches are placed in parallel to each other. For instance, you have a switch here, and then you also have another switch here. Connect them in parallel to each other, and this is the positive terminal. Let's say we connect this path to a particular circuit. Let's say a resistor capacitor circuit here, and then this is the negative terminal. Let's say we have 5 volts here to flow into the circuit, that is to power the circuit, but we have two switches here. This is switch A as well as switch B here. So we have two switches here, switch A and switch B. Now if this 5 volts is made to power this circuit, the 5 volts cannot power this circuit because there are two switches here and both these two switches are open. We have switch A and switch B. Now the 5 volts we try to pass through switch A to power the circuit, but it cannot because switch A is open. The 5 volts also will try to pass through this switch B. It can because switch B is open. But if we close switch B here, you will find out that the voltage will now pass through switch A here, and then it will power the circuit. If we also close switch B here, still the power will now pass through switch B and also power the circuit. But if we open switch A, remaining switch B closed, the power will still pass through switch B to switch the circuit, but it will not pass through switch A. So either of these switches will power the circuit. If switch A is closed, leaving switch B open, the circuit will still be powered. If you close switch B, leaving switch A open, the circuit will still be powered. Now, the circuit diagram of an OR gate look like this. This is just a rough diagram. Then we have the output here, which is D. Now, the truth table of the OR gate here, let's say this is the A plus B equals to D here, that is the output. Now, in electronics, as we said earlier in the previous video, when we talk about 0 here, we mean off, and if we say 1, we mean on. It is the same thing here, open, and also it is the same thing here, close. So if you see 0, meaning the circuit or the switch is off or the switch is open. If you see 1, meaning the circuit is on or the switch is definitely closed. So now we are considering the truth table of the OR gate. Now, if both switches are open, which is 0, are open, meaning these two switches are open. Now, if the A switch is open and B switch is open, the voltage should try to pass through switch A to power the circuit, but it is open. That is 0. This also is open, 0. So if we say 0 here plus 0 here, what will happen here? It is still going to remain 0. That is, it is still going to remain off because both switches are open. So the 5 voltage will not power the circuit. So since here is 0, here is 0, so there is no input here. So the output is going to be 0. Now, in case we close this switch, this is 1, we close this switch A, leaving switch B open. So if we close switch A here, leaving switch B open, now the power will still pass through switch A and then the circuit will be power, despite switch B is open. Since switch A is closed, the 5 volts will now pass through switch A and then switch on the circuit. So if you have switch A closed here and you leave switch B open, so there is still going to be an output of 1 here because the voltage will pass through switch A and then open and then switch the circuit despite switch B is open. So since there is a power to the circuit when switch A is closed, then we have here 1 because there is going to be an output. As well as if we will leave switch A open and then we close switch B here, what will happen? Switch A is now open and switch B is closed. So this, instead of the switch A, the voltage to pass through switch A, because switch A is open, it cannot pass through switch A. It will now take this path to pass through switch B to power the circuit because switch B is definitely closed. So switch B here will be 1. So switch B is open. So here too, switch B is definitely closed, where switch A is open. So power will still pass into this circuit and then there is going to be an output. So if we open switch A and then we close switch B, there is still going to be an output because power will pass through switch B and power the circuit, but it will not pass switch A because switch A is open. And also, if we close switch B and then we close switch A, if we close both switches, switch A is closed, switch B is closed, the 5 voltage will still pass switch A to power the circuit and it will still pass switch B to power the circuit. So even though both of them are closed, the circuit is going to be switched on. Even though one of these switch is closed, leaving the one open, the circuit will still be switched on. So if we close switch A plus switch B here, there is still going to be an output. So that is exactly how the OR gate is. Now, let's also talk about the NOT gate here. The NOT gate. Now, what is actually the NOT gate? The NOT gate is also known as an inverter because the input is really the inverse of the output. That means if the input is on, the output is off. If the output is 0, then the input will be 1. For instance, if you have a circuit like this, so let's say this is the output and this is the input A. So when here is definitely 0, here, this switch is already closed. So now the voltage is still passing through this volt here because the switch definitely is closed. So here is going to be 1 and here is going to be 0. So the input is definitely the inverse of the output. So if you have 1 here, meaning when you apply a input here, the switch is going to open. So here is going to be 0. If there is no input here, this switch will be closed and there is going to be 1 here. So that is just how the NOT gate operates. Now, the circuit diagram of a NOT gate look like this. Remember, this is just a rough diagram here. This is the NOT gate. I'm sorry. This is the circuit symbol for the NOT gate. Here, and then have this point here this way. So we have A here and then we have the output here. So the inverse, A is the inverse of D. The input is the inverse of D. So if A is 0 here, meaning if A is off, the output is on. If A, the input is on, D here, the output will be off. So that is how the NOT gate functions. It is actually an inverter. That is the other name for the NOT gate. And the input is the inverse of the output. So the truth table here, A is equals to D, which is the A is the inverse of D here. So if A here is 0, then the output will be 1. So if A is 1, then the output is going to be off. So that is exactly how the NOT gate operates, and that is how the truth table look like. So thank you very much for your audience. Please don't forget to subscribe, like and share. Thank you very much. In the next video, we are going to demonstrate practically the explanation we have made here. You will see the practical functions of what we have definitely illustrated in this theory video. The practical aspect will give you the practical idea about what we have definitely explained here. So thank you once more again. In the next video, we are going to talk about another gate, which is the NAND gate and the NOR gate. So stay Thank you very much. Thank you.